the Sustainability Management Master's Program, you are answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
This seminar is sponsored by BEM Systems, Brown and Caldwell, and brought to you by the Stevens Institute Center for Environmental Systems.
Good evening, everyone. I want to first and foremost wish you guys a happy Valentine's. It's not yet, it's not today, it's tomorrow, but here we go. So just a bit of background. Thank you for the introduction, by the way, Dr. Sarkar. And as Dr. Sarkar mentioned, Professor Angela Elmi, who teaches here on your environmental law and management course, I believe some of you have taken his class, works with me at MTA New York City Transit. He's one of our principal environmental engineers. He's invited me to speak at his class twice already. Well, once last spring, and then Dr. Sarkar also invited me on a panel discussion last semester as well. So I'm very thankful for having me again to present my topic on energy codes and high performance buildings. Before I get into it, I also want to thank Professor Abdallah, who teaches at Columbia University, but is also the Chief Environmental Engineer and Senior Vice President at MTA. I work very closely with him there as well. Stage right.
She can go full screen, right?
Yes. Okay. So our topic for the evening today is energy codes and local laws guiding a sustainable future for high performance buildings. How many of you are in the sustainability management program here? How many of you are in finance, environmental engineering, electrical engineering, plumbing engineering, and architecture? Okay. So I'm going to touch upon all of these disciplines because my focus is primarily in the built environment, meaning buildings, commercial buildings to be specific. But here, let's do this. So I started USL Technology in 2011. My background is in computer science. I worked in the telecommunications, wireless telecommunications industry for about 8.5 years for T-Mobile out in Seattle, Washington. And throughout my career, my main focus has been in the data center environment. So I've done data center design, systems integration, commissioning large gateways and servers and routers to support T-Mobile subscribers. Back when I worked in the private sector back in 2006, at that point, T-Mobile had about 30 million subscribers. So think about the servers and the data center environment that supported 30 million T-Mobile customers. I'm still a T-Mobile customer, Now they have about 90 million to, I think, 95 million subscribers. So that's the magnitude of the types of systems, integrated approach of systems and software that I have employed throughout my career, not only in the wireless technology sector, but also in the financial sector. I worked out in Wall Street, also as a data center network engineer, doing onboarding and integration of institutional clients on State Street Bank's data center environment so they can trade on foreign currency trading platform systems. Now, when I went to Columbia in 2013, my goal was to pivot my company from a pure IT infrastructure redesign and integration company for small to mid-sized businesses to kind of find a niche in the market and focus on data center energy efficiency. However, as you may know, with any innovation and innovative sector, as in sustainability, a lot of solutions don't really hit the market right away. So about 15 years ago, Cisco Systems, as a network engineer, Cisco builds routers and servers and switches. So as a Cisco network engineer, Cisco came out with a software called Cisco EnergyWise, and it's an energy management system that ran on the IT network. And that's kind of how I got my interest got piqued to look at the cross-section of energy management of IT assets in the data center environment versus energy management in the built environment, looking at heating and cooling. But nonetheless, when I looked at building management systems, I figured it's a system, it's a technology running on it. That's an opportunity for me as a software and systems engineering background to be able to look at buildings as a whole from a systems thinking approach perspective in providing efficiency to data center owners and data center providers because they run 24/7, 365 days a year, and energy consumption, we all know, nowadays we all have mobile and smart devices, and they're all interconnected and consuming energy day in, day out. So that's kind of where we are today with my company, looking at buildings in the commercial sector. And when I say commercial sector, I'm looking at hotels. So I work with hotel owners. We're also looking at data centers as well. We're looking at facility companies like Manhattan mini storage type of companies and warehouses. They're industrial buildings, but also supermarkets. And what these types of buildings have in common is energy consumption and water consumption. And that all leads into fossil fuel consumption, and that how that kind of constitute to the city of New York and the state of New York's bigger goal of reducing their GHG emissions. So that's kind of the framework of my presentation from a buildings perspective and how the industry is moving towards a higher performing, meaning a more efficient building that uses less resources in terms of energy and water. And also looking for clean energy, PV, clean energy opportunities. But these things are some things that, unless you understand the initial building's energy profile, looking at solar may be a little bit premature, but that's part of the trajectory of how we develop our strategy. Now, I'm using the context of New York City because that's where my company's focused and that's where I live. But a lot of the information that I'm going to be sharing here has been adopted by different states and different cities. They may call their programs and their initiatives differently, but the takeaway here is if you live in New Jersey and you want to know what the state of New Jersey is doing, there's a framework that's already existing because best practices have been running in their climate action initiative in this country since, I would want to say environmental engineering and environmental science has had its movement since in the 60s. Now we're coming at a cusp where things are actually moving a lot faster. So in 2009 is when the city of New York basically came up with a suite of New York City local laws. But as you understand, when it comes to policy and laws, it's also cyclical, meaning, whoever the mayor is or whoever the governor is after their four-year term is over, the newer person that comes in would either adopt some of those initiatives and also introduce their own. Now, 80 by 50 is the latest initiative in New York City, and the intent is to basically reduce New York City's carbon emissions 80% by 2050 from 2005 levels is like the baseline. Now, as part of that initiative, the city came up with a plan called One City Built to Last. So I'm giving you just like a high-level summary of it, but these are like 300, 400-page plans that we leaf through as professionals to kind of understand the context as we work with building owners in both the private sector and the public sector because they need to comply with these laws. So One City Built to Last is part of the 80 by 50 initiative by the Mayor de Blasio's goal, which came out in 2014. Now, as part of One City Built to Last, it's a 10-year plan. You know, it could be a 5-year plan, it could be a 10-year plan, but realistically, in a city like New York, you can achieve a lot more within a 10-year span. And the main goal of the whole One City Built to Last is to basically reduce emissions for both government-owned buildings and private-owned buildings, right? In the city of New York, and as in many city and states around the country, you have to lead by example. You put together these policies, you turn them into laws. You want to make sure that your facilities and your own properties are actually efficient. You're using energy. You're improving your energy consumption. You're improving your water efficiency, and then the private sector obviously, naturally, hopefully, will follow because you're leading by example. Most of us have been to New York City. There's buildings everywhere, right? So there's over 1 million buildings in the 5 boroughs. And this is just focusing on the 5 boroughs of Manhattan. And 76% of energy consumption, carbon emissions today come from buildings. And about 80 to 85% of those is from multifamily buildings. So my company is not even focusing on the larger building stock, but looking at commercial buildings, they may be a smaller percentage of the pie, but they are heavy, heavy consumers of energy as well. So I just wanted to give you guys a context of the amount of work we have ahead of us and the opportunity that's there, one building at a time. So as part of One City Built to Last, so cities and states are being leaders in this industry, because unfortunately when it comes to environmental issues, when it comes to climate change issues, it's under our state governments and our city governments' purview to help lead the way. And they're putting programs and best practices and policies to help guide us on how to get there. So as part of de Blasio's plan, these are the core areas that we're currently working on. We've been working on in the past 3 years. And there's currently an opportunity that once these programs end in May, there will be subsequent programs that's basically going to extend the good work that everybody's been doing, focusing on needs that's going to take us for the next 3 years from 2019. Now, Retrofit Accelerator is mostly focused on energy efficiency and water efficiency. And I'll go into the laws that kind of govern what goes with that program. Retrofit Accelerator, I'd like to say that it's focused on commercial buildings, but it's not really that hard, it's not really that set in stone. Community retrofit is mostly for smaller buildings, mostly multifamily and single family. And there's this program called the Benchmark Health Center, and it's basically the lowest level of initiative that any building owner would need to do to baseline their building, meaning benchmark it in terms of what resources are you using every month. Have you analyzed your utility bill to see how much you're paying? Because once you benchmark it, then you have an idea of what your carbon footprint is, what your consumption footprint is, before you can start putting in smarter and more sophisticated strategies. So as you can see, there's a lot of local laws. Now, the first generation of New York City's plan was under Mayor Bloomberg, and it was called the Greener Greater Buildings Plan. De Blasio's plan is the One City Built to Last, and also the 80 by 50 initiative. But as I had shared earlier, these laws don't just disappear once the mayors leave office. They get built on and then it gets carried forward through the years. Now, in 2009, a series of laws were passed to improve energy efficiency, access to energy data, because data is king. Like, if you don't have data so you can start measuring and managing, then you're like using files and paper-based work, and we know that's not the most efficient and effective way to go about it. The first law that came out of that suite of laws back in 2009 is Local Law 84. So this is, as I mentioned earlier on the benchmarking health center, this is what they do. So this is basically submitting your utility bill for all your different fuel types to show your consumption year over year. So in the platform that everybody uses in New York City based on the law requires you to upload that data into Portfolio Manager. So Portfolio Manager is an EPA database that they maintain and support for the entire industry in the US. Now, as some states using it, that's debatable because there are some states that are still deciding if they want to believe in climate change or not. So, but the consensus right now that's happening is with Local Law 84, you benchmark your building, and it helps us all as a nation when we make these commitments. When you look at certain building types in New York City, or let's say in Manhattan and in Brooklyn, and you're doing data analysis, you can compare, apples for apples types of building. And that's why the requirement is to upload this data into Portfolio Manager, which is more of a national database. Now, the accuracy of the data also is debatable, but as in anything, you got to start from somewhere. There was a point, before 2009, nobody cared about their utility bill. Most of us can't even read our energy bill. It's a challenge to read that energy bill. That alone by itself is a career path. Now, after benchmarking, after Local Law 84 became effective in 2009, the one that followed is Local Law 85. Basically, this is the Energy Conservation Code. The Energy Conservation Code is sort of along the lines with the building code, the mechanical code, the electrical code, and the fire code. So whether you're designing a new building or retrofitting an existing building in New York City, you need to comply with the New York City Energy Code. And the compliance, I believe, started in 2012, even though it was enacted in 2009. And it started in 2012 because when you come up with these laws, you kind of give the industry a little bit of time to get acquainted with these new laws, know where to go for help, how to comply with it before architects and engineers submit their drawings to your Department of Buildings. Plan reviewers are going to look at it and see if it complies with the energy code or not, and that kind of affects your permitting process, whether you're doing a major renovation project or a new building design and construction project. Now, Local Law 87 is the follow-up to Local Law 84, and this became effective, I believe, in 2013. So once you benchmark your building, now you know what your energy profile is as a building owner, and building owners will hire consulting companies like my company, USL Technology, to help them with this process, right? Because typically, if you're a hotel or you own a supermarket, the last thing you want to do is start trying to learn what Local Law 87 meant. So this creates a market for students like yourself and for professionals like myself, and I was a student once, but once you figure out where you want to focus in your career, these types of laws are areas that you can tap into, whether you work in the private sector, public sector, or you become an entrepreneur. If you're going to be in the green building space, in the high performance building space, especially in New York, these laws are not going anywhere, so it's very good to know. And basically, Local Law 87 requirements isn't even asking you to rip out or upgrade majority of your infrastructure that's in your building. It's asking to actually audit, do a site walkthrough, right? Look at how many different light fixtures you have in your spaces. How much energy, how much wattage each of those fixtures are consuming. Can you replace them with an LED, right? How interactive or how much do you want to integrate those LEDs with controls and sensors to further drive down energy consumption? So these are the types of analysis when you comply with local law 87. And that all goes into heating and cooling system as well, your rooftop units, your boiler systems, your chiller plant. And then with local law 87, if you have any deficiencies doing your compliance year, because local law 87 is, you have to do it once every 10 years. So it's a very, very detailed technical engineering due diligence that's involved in it. And it can also, there's a lot of cost implications, but there's also a lot of economic savings opportunities. Now, local law 88 is in effect currently as well. This is basically requiring spaces that are larger than, I think, 10,000 square feet to sub-meter that space, right? Because when you have a space that's that large, it typically will be used, it would use lighting for a lot of reasons. If it's a conference room or a banquet room, you're going to deal with a lot of heating and cooling, different temperature set points, how many people are going to be, all these different factors really goes into sort of like the operational conditions of that space. And the larger it is, when you sub-meter it, then you get to know what areas within your building consume a lot more energy, right? And these are the opportunities that you have to look out for when you comply with local law 87. It doesn't, if you're a small building and you don't meet that square footage requirement, you don't need to comply with this one. So all the previous laws I shared were enacted in 2009. Now, it's not like we didn't have enough laws. A series of new laws also came into effect in the past 3 years. I think the takeaway that I always tell clients when we're doing business development, trying to get their business, is explain to them that when you look at sustainability, you're looking at the environmental, the social, and the economic benefits. We call it the triple bottom line of sustainability. And because it's governed by laws in different cities and states, if you want to gain the economic benefits from implementing a lot of these solutions, you have to take a long-term strategy approach rather than a short-term strategy approach. So the earlier building owners start complying with these things, because these laws are getting more and more stringent, the better it is for them, and the sooner they can start saving, meaning reducing consumption, reducing cost, but yet still complying. Now, 2014 is when these additional laws kicked in. And the beauty of it, at least from us as professionals, because these laws are not independent of themselves, they're all interrelated. The newer ones kind of piggyback off of the old laws, because it's been since 2009, so there's a lot of lessons learned from the implementations. And that's why these additional laws became necessary, because we look back and say, this is how we're going to get to 80 by 50. And in order to do so, we're going to close that gap. And so local law 33, I just have these things in order by the numbers, but the ordering has, this part of it, the ordering really doesn't matter. But the previous one, the ordering mattered, because you have to benchmark before you start doing auditing, and there's a flow to those. Now, I love this one. We all know restaurants get graded if they are clean or not, right? Same thing is going to be happening with energy in New York City, which to any owner, it's actually a huge, huge sort of like, if you're a hotel and your hotel has a grade A for efficiency, that means you're using water more effectively, you're using energy in a more efficient way, you may actually even have renewables in your building. We're seeing more and more where people are starting to book hotels that are more sustainable. I mean, most of these buildings, it depends if you say, what do you define as sustainable? It's a process, right? But knowing that building owners are actually taking these initiatives and they're actually doing something and they're being vetted and verified with programs like this that's independent from the owners, kind of is starting to be the norm and give us a confidence that when we spend our money with businesses, because we can choose where we spend our money, with businesses that have goals that align with our goals, whether it's in investments, right? Sustainable investing is another area where you want to invest in funds that are like not chopping down trees in, I don't know, the Amazon forest and stuff like that. So basically, this is requiring buildings to start being a lot better at tracking their data. And this ties into Portfolio Manager, which I shared earlier. So when you input all your different fuel types in Portfolio Manager, if you have, let's say, natural gas, electricity, fuel oil, and how much you're consuming, at a Portfolio Manager scores at a minimum from a 75 to 80 to 100%, right? Now, your score is dependent on how diligently you input that data, right? Data is very interesting, garbage in, garbage out. Like most of these owners are actually doing really amazing work because they've complied with Local Law 84. It's been around since 2009. Now this actually will allow them to see if they're getting a score of, let's say, 40, and you've been complying for the past 6 years, you definitely know that you need to go revisit that data and input it so your score can improve. But these are the types of checks and balances that, as a city or as a state, you cannot just go from 0 to 10. It's a process. You start, doing small things, and then as you do small things, it helps us professionals to be able to help encourage owners to do these things. Okay. Yeah. So as I mentioned, this expands on Local Law 84. Now, Local Law 32 expands on Local Law 87. Oh, sorry, Local Law 88. It expands on 88 in the sense that now it's covering buildings that are 5,000 square feet and larger than 25,000 square feet. So originally, when Local Law 87 came out, it was only looking at buildings 50,000 square feet and larger. So a lot of smaller buildings in 2009 up until 2014 didn't have to comply because, for many reasons, economic reasons, they don't have perhaps that much of a footprint as the larger buildings, but that doesn't necessarily mean that they cannot be part of the solution to help meet that 80% by 2050 goal. Local Law 33 expands on, 133 expands on 84 as well. And that includes city buildings. So Local Law 84 is benchmarking. So Local Law 133 is also benchmarking, but benchmarking smaller buildings. Local Law 84 was benchmarking larger buildings, 50,000 square foot and larger. Local Law 134 expands on Local Law 88. Local Law 88 was the submetering requirement and the lighting of spaces that are larger than 10,000 square feet. Now here is the gross square footage. Now it's smaller, so smaller spaces are now also being required to submeter and also do lighting upgrades. So those are the laws. And now, one asks, how do these laws translate to a high-performance building? Or perhaps, what is even a high-performance building, right? It's subject to definition, but my definition of it is basically looking at integrating and optimizing major, right? Some people like to game the system. They'll do their little things and they want to say, oh, my building is green, my building is efficient, my building is LEED certified. But as a society, we need to be responsible for what we bring into our spaces, our impact on the environment. And when you're a professional in the industry, the only way we can make that 80% carbon emission reduction is by looking at deeper opportunities than just scratching the surface. So now, major means it has to be material, it has to be relevant, you have to be doing something substantial. And that includes efficiency of water, air quality, because we're in these rooms for such a long time. If ventilation system in this space is awful, it affects our health, right? And this is why when we communicate to owners, we actually bring it home to what's relevant to them, rather than keeping it at a very high level. Because when people can relate to the challenges, then they're more eager to actually do something about it. Now, durability and sustainability. I kind of interchange those together. Because, when you have a long-term approach, some things require capital investments, Some things don't require that, but durability and something that you can sustain for over 15 years, 20 years is something that it may be capital intensive, but when you do a life cycle cost analysis for some of your projects, it may make sense to bundle some of these projects, to do some sooner, do some later, but nonetheless, it needs to be looked at holistically. Occupant productivity, as I was saying earlier, we are the major cause of environmental issues, right? And we're the ones who occupy these spaces. And we want to be comfortable. You go into a space, it's too cold. If it was too cold in here, you probably wouldn't be paying attention. So these are the things that we really bring home and make it very simple, because from a technical perspective, from a technology perspective and engineering perspective, there are frameworks and methodologies that tell us how to do these things. But unless we communicate it in a way that we understand what our impact is, sometimes we don't really, want to do it, or we just don't care. But once we know the impacts, we are more eager to do something about it. Hold on, let me go back. Now, I'm tying high performance to the local laws. I'm going to talk about the market trends, because the market demand is very critical. If the market demand is driven by innovative technologies that are available, and again, if technology solutions are not available, if best practices and engineering practices are not available, these local laws would not have happened. So we focus primarily on the commercial sector, but I wanted to also show the trends in the residential sector. So I'm not going to go into the specifics of the local laws, but I've touched upon it. I should have given credit for this shot. I stole it from somewhere. But the takeaway here is code is basically the law, right? And it's only a small piece of the pie, right? For owners who are investing, there's a huge amount of opportunity to do deeper, more meaningful implementations that are economically smart to do, that are environmentally smart to do, that are also socially smart to do. Because at the end of the day, it's our aunts and our cousins, our grandmothers and our babies, and that are crawling on carpets that have volatile organic compounds. You know what I mean? We're the ones, when you paint a room and you walk in there, you're smelling all these different chemicals. And I don't, it's like you think about these things and you bring it home. When you're in this field, you explain to your clients what really matters, because when the work is done and it's done right, the economic benefits are there. And then the carbon reduction goals that we're all pursuing as a society, from a climate change perspective, from an environmental perspective, will happen. So this is just showing that compliance isn't necessarily a bad thing. It just it helps you set the stage to do more. And then you can even reap more economic benefits by doing that. These are the first generation of local laws. I already went through all of them, just wanted to sort of iterate on that. Now, the trends that I had mentioned, actually, the laws, so this slide is an ASHRAE. How many of you know what ASHRAE means? Right? ASHRAE, American Society of Heating and Air Conditioning and Refrigeration Engineers, right? So basically, ASHRAE, the Energy Code got enacted in 1975, and this was during the oil embargo. Some of us were not born back then, but so these issues have been around for a long time. And this just shows you, from a percentage perspective, when the code first came out, 100% of the energy that was required for buildings at that time. Now, hold on, let's see, we're in 2000. Let's see, so let's just go by 2015. So in 2015, ASHRAE 90.1 2013 standard came out. Right now, this ASHRAE 90.1 2016, that's the latest version of the standard. Now, 50% of consumption, less energy was required back in 75, right? And I believe that with the newer ASHRAE code, which is like 90.1 2016, now it's probably like at 30% less energy consumption in buildings when you compare it to when the code first came out. in 1975. So the stringency is getting more and more stricter. And from a compliance perspective, for building owners that don't want to do anything, now when they need to do a major renovation, they have to do a major overhaul to comply with this law. So that's kind of like the knowledge that owners need to realize that you do it earlier, it kind of helps you along the way when it comes to doing major projects. And essentially, net zero buildings, also there's a major definition, around what you consider a net zero building. But the takeaway here is that if you're not even a net zero building and your energy consumption by the code is already at 30% less than 1975, if you want a net zero building, why don't you start complying with the code, right? So as I mentioned earlier, future codes would be stricter, and this is more of a breakdown of, where it was with lighting power density, building envelope, heat transfer, cooling equipment, heating equipment, and just an overall ASHRAE standard, right? So the trajectory is just going less and less and less. And the category basically is all the different energy consuming systems that are typically in buildings and that most buildings have to comply with the energy code. So this is more of a industry data. I think what I find very fascinating when I look at where the market is going, I shared earlier when I introduced myself that in 2005, was it 2003 or 2, is when I came across Cisco's EnergyWise software, and I was so excited about it, but the industry just wasn't ready. I mean, you start sharing this with people, and they look at you like, what do you know about buildings? And that's not doable, but that's because the whole concept just was so abstract. And now, what we're seeing now in the market is that it's not abstract anymore. You go talk to a building owner or a facility manager or a property manager, they know what LED does, how much energy reduction you can get from using an incandescent light bulb. I mean, there are more sophisticated things that can be done in buildings that require smarter technologies that are still not being capitalized on, but again, it's a process, and we're getting there closer and closer. But the takeaway here is that in the commercial sector, the green market is this dark sector, so it's pretty small, right? And this is the traditional construction industry sector. In 2015, it's at $93 billion. It's at $20 billion in the traditional market, right? But you can see that it's growing, going from 48 billion to 120 billion in 2017 is the projection. So if you're a professional who wants to be in the green building space, and you need to consult with either private building owners or public sector building owners, from an investment perspective for them to do some of these projects, the materials are there. You guys have a material science program as well. When you look at the building envelope in terms of wall assemblies, insulation, pipe insulation, these materials are what constitute some of these markets that are being generated and for some of these local laws that are being put together so owners can comply with it. So when they do their engineering drawings, they can show what materials are being used and have all their thermal properties in there and show how it's complying with the code. Okay. So residential building, I'm just going to go through this quickly, but the green residential market is that small part of the chart. The larger part is that. Residential market isn't as what do you call it? The growth isn't as exciting as it is in the commercial sector, but nonetheless, it's also, there's an opportunity there. Now, from a high-performance building perspective, you have to have smart technologies in your buildings, meaning you want to have controls and sensors, where it is with your heating and cooling system to control temperature, to lighting controls and sensors, occupancy sensors. You also want to have them integrated into a building management system. So the process can be automated. Now, building management systems are nothing new. They've been around for a very long time, but they basically tell you the health and state of your systems that are within your building. But from an energy efficiency and energy management perspective, we're talking about an energy management system. So in conjunction with a BMS, you can not only see how your systems are functioning, by looking at fault detection errors and alarms. When you start looking at these faulty systems and you're actually looking at how they're behaving and how they're consuming energy or not consuming energy, you have visibility into it, right? So why do you measure and manage? This is a huge part of a high-performance building, and it's a huge part of the different local laws and the requirements that come underneath them because they're baked in there. So as professionals, that's why it's important to know what these policies are, when the changes are happening, how does it affect your clients, what systems are within their environment, so you can advise them in a much better way because they have to make smart business decisions. And as an engineer, I don't like giving estimates without looking at data. It's like, forget about it. Most people want to tell you, am I going to save 30%? Well, I don't know. I need to go in your building for one. I need to see what's currently installed. And if it doesn't have a smart system in there, that doesn't necessarily mean it's the end of the world, but that gives me an opportunity to start putting together different measures and recommendations that they should consider, right? So are we there yet in terms of building stocks in New York City that you would consider a high-performing building, a sustainable building? Yes. To what extent? On a scale of 1 to 10, it varies. And I think we have a long way to go in the next 5 to 10 years before we can have like a building management system in conjunction with an energy management system, lighting fixtures being controlled by sense, because when you swap, let's say, I use lighting because it's a lot easier to demonstrate some of these things. You have an incandescent light bulb that's, let's say, 100 watts. You replace it with an LED that's 24 watts, so you have a direct wattage consumption reduction. Now, if you don't integrate that with controls and sensors, that's all you get, 24-watt LED light bulb. But if you integrate it with controls and sensors and it gets commissioned into the building management system, it gets monitored by the energy management system. Now, and then you have a schedule of the space that you have the sensors in. Now you can see if it's reducing that wattage consumption a little further depending on how the space is being used, right? And this goes with your heating thermostat, your cooling system, because if there's nobody in the room, you don't need to heat it at 75 degrees, right? So when you reduce it down to 60, that's a huge, huge energy savings opportunity. But I personally can't make those statements to a building owner if these systems are not there. So that, to me, that's what measurement and verification is about. That's what high-performing buildings are. That's part of compliance as well, because it's all part of the solution mix. Hold on, let's see. Okay, so I did touch upon this a little bit, but so energy codes and local laws, they all combined help us get to having a high-performing building, whether it's a new construction or an existing building retrofit. Also, if not for anything, energy cost is just increasing year over year. This is in New York City, right? It's increased 20% since 2002, and it's not slowing down, right? It's the heating season right now. Natural gas is super expensive. Electricity per kilowatt hour is also expensive. Fuel cost, whether you're using fuel oil or natural gas is still increasing. So real-time data, this is basically part of the whole solution, and it's not necessarily where it ends, because once you have access to this data, you need to be able to measure it and verify it. And it's a year-over-year process. It's an ongoing process, because we go into these changes, we change settings, right? You can perfectly configure things, and it's working fine. Somebody comes in and tweaks it. But when you have visibility into it, now you can see maybe the way it was initially commissioned and tested was not appropriate for the type of occupants that are in that space. Because you don't also want to be not flexible in these types of set points. Because if it's not accommodating the occupants, things are not going to work as you anticipate. So it's always a continuous process of measurement and verification to be able to kind of maintain those emission reductions that you're getting after the implementation, to get those cost savings reductions after the implementation, because if you don't measure it and verify it, the savings may not be realized. So, I mean, a lot of times you're talking about return on investment or return on equity. These are bold numbers that I personally believe that you have to be cautious if you say I'm going to reduce your consumption, whether it's water or energy, by 35%. What does that mean? You have to do a lot of upfront due diligence. You have to analyze the utility bill to even understand how much they're spending, how much they're consuming, hence the different laws, right? And then once you understand that, then you know what conservation measures are relevant within that space to start recommending things for them to do, maybe not all at once, but at different phases, right? And then again, it's a continuous process, because you do it once and you get a 35% reduction in 2019, and you're like, awesome, I'm not doing anything anymore. 2020 comes by, you haven't done anything in a year, you're not going to get that 25%. It's just as simple as that. And sometimes, the industry is still trying to encourage owners to understand the reality of sustainability isn't something that you do once and it fixes itself. It's an ongoing process. So this is technical assistance. So my company works as a subcontractor under the New York City Retrofit Accelerator Program. So all those local law 87, all this information I went through, we do it day in, day out with hospitality, hotel owners. We're starting to engage supermarkets, because it's a completely different sector. There's not that many of them compared to residential buildings or commercial buildings, but supermarkets from a cooling perspective and refrigeration perspective in terms of refrigerants. We're talking about refrigerants with global warming potential. So these are other things that we're looking at beyond just energy, right? We're looking at chemicals that are in these cooling systems and heating systems to help advise them when the units reach their end of life. So the technical assistance part is the program that allows professionals like my firm and many other companies who are subcontractors on the New York City Retrofit Accelerator Program to advise owners for free, because the city pays us to do that. And the city sees a lot of value in that, because they have this big, bold initiative to reduce consumption 80% by 2050. And that's not going to happen if we as professionals are not involved in it, going out and knocking on doors and educating owners and encouraging them that there are major, major economic benefits for doing these things, but also a major social benefits and environmental benefits as well. And that includes new construction and existing buildings. We coordinate with utility providers. Con Edison is the major one in Manhattan. I'm sure New Jersey has theirs as well. NYSERDA has incentives, and we work very closely with Con Edison, NYSERDA, and other consultants that run some of these programs on behalf of the utility owners. Quality of service by training. I mean, we are in a field where you can't get comfortable by knowing one thing. You're consistently learning. There are newer things coming out, best practices coming out. So whatever we do, we try to engage our clients and their staff, because they're the ones that maintain these systems day in, day out. They're much more intimately familiar with their buildings, so it helps just kind of show for them and for us, understand better what they're contributing towards climate change, what is their building's energy profile, what is their building's water profile, and what better person to maintain that than their facility managers, their general managers, or being able to even share that with people who occupy their buildings. So intent is to expand access and benefits of energy efficiency and renewables and water efficiency for New York residents, but for the United States as a whole, pretty much.